So welcome everyone to our CCNA 1 meeting for the week of the, guess be the 5th of this week. I am going to share my screen over here, screen 2, and talk about this email was just sent out to everybody, but it is on what needs to be finished by the end of class. Now, technically your class does end on July 12th, according to our SCC schedule, but I am not closing NetAcad access. I am not stopping NetLabs access. So you have up until the 26th of July to finish the CCNA 1 class, then we'll get started in our CCNA 2 class. The great news is CCNA 2 follows basically the exact same format as CCNA 1. So you're not going to have to relearn the systems or the way to get around in things. So I think once you get into CCNA 2, you'll find out it's a little easier for you because you already have learned how everything works. And that's very true too, folks, for your own students. In fact, one of the things I'm going to be doing in the next couple of weeks is one of our class meetings. I'm going to be talking about how I'm going to walk into my lab, show you my lab. I'll be on my phone with Zoom so I can show you the lab itself and kind of give you an idea of how things work in a student class, because if this was a student class, I'd be doing things a little bit differently, not a whole lot differently, but a little bit differently than what I'm doing now. First off, I'll be more stringent on grading and on staying in sequence with the assignment due dates. That's something I do with my students because we know how students are. But for you, what you've got to finish at this point is to complete the module exam. So you do need to finish those. Every module has its own exams. I did have a mistake on your setup for the module exams. I didn't have them set up to let you do them up to 10 times without me re-enabling them. So I actually went in and deactivated all of your exams and reactivated the module exams. So they are set up now to where you can take them up to 10 times each. But you do need to take all of the the module exams. I call them chapter exams because we used to have chapters. But you'll notice there's one at the beginning of each module area, and those need to be completed. Number 2, there is a course feedback inside of NetAcad. And the only reason you must complete this is because Cisco makes this a gate or checkpoint before you can take the written final exam. So you have to do the course feedback inside of NetAcad for me. I also ask, if you don't mind and you have time, go into canvas.stanley.edu and do the course evaluation there under our course. If you log into our course, you'll actually see it in the course on the left-hand side. It'll say course evaluation. It's funny, I never get course evaluations because I'm so bad about getting instructors to do it. But if you can, do that. But this is what's required. You've got to do this course feedback inside of netacad.com. Once that is done, you'll be able to do the written final exam. This exam, by the way, I can only turn on for up to 7 days. So under this assessment center here, when I go into create activations for you, and this is again something we'll be going on, you'll notice there are no available activations right now for the final exam. So I'm going to actually turn it on for the next 7 days. And I'm going to give you up to 3.5 hours on the exam, and it will be in a less secure environment. And then you will now see, if I look under manage activations, that the final exam should be listed here as an exam. Let's see, there it is. Yeah, final exam right here. So it's available. On July the 13th, I will go back in and enable it again for another 7 days. So it'll be on now pretty much from now until the end of class. The final item that you've got to do is the hands-on skills assessment. Now, this is done in NetLabs. You'll notice everything else is in NetAcad, but your hands-on exam is in NetLabs. I sent it to you in an email for you to look at. So you're going to actually already have the documents that you have. And you'll notice I've asked that you use this network and these number of hosts for each subnet to do your subnetting for the hands-on. But when you do this, you've got to schedule this as a lab on NetLabs. So we go into NetLabs. Okay, you'll log in. You'll schedule a lab for yourself. Find your course, which you will not have all these courses like I do. You'll be in the second cohort, and you will schedule a lab using this lab right here, the skills assessment. That's the hands-on skills assessment pod. So you click here, and then you can use any of the 16 pods we have available. All right. So that is what you need to do for the hands-on final. I will then have you upload it to this particular upload, okay, which is inside of NetAcad. So if we go back in NetAcad, you'll see that down at the very bottom of our course home, you'll see that you have an item that says hands-on final skills exam with equipment, final skills equipment. You click here, and this is where you can upload, you can submit your completed documents. I will then, once you submit that, I will go into NetLabs and look at your NetLabs and see exactly what you put in to make sure you put in all of the different items that are necessary. The other thing you will notice, and I mentioned this inside of here, is that in the document, it says in many parts, wait for the instructor to sign off. In a classroom setting, or if you were students, we would be doing secured hands-on assessments. I would actually have you in Zoom one-on-one with me doing a hands-on skills assessment inside of NetLabs. That way I could watch you and I could see what you're doing and make sure you're not using outside notes or having someone else do it. As part of that, that's why it's designed for the instructor to sign it off. In other words, I sit there and I look at the first part and say, okay, good, now you can move on. For you as instructors, we don't do that. We just ask you to complete the entire skills-based assessment inside of NetLabs, and then I will go and grade it once you've completed it. Are there any questions as to what you need to complete in order to successfully finish the CCNA 1 class?
Just quick question, just to verify. So all of the items, even though right now on the capture they are due July 12th, they're going to be available until July 26th.
Yes, they will. All I've got to do is, in fact, I noticed that too. I've got to go into, let me go in here and change the course date. I had this course ending on July 12th. Yeah, I'll go change this. I'm going to change it right now so it will show you. So you have until the 26th. Yeah, all of those items are available until at least the 26th.
Okay.
Okay. And so just let's try our absolute teetotal best to get everything done by that date so that we can get started on CCNA 2.
Okay.
On the 27th.
Thank you.
Yep. And that should change as soon as I get this finished up. Any other questions? Okay, so there's a good amount left to do. Many of you already have done most of the module exams or several of the module exams. So you're not in too bad a shape. Everyone's in pretty good shape here. So now, any other questions? I do want to show you something I actually saw and found out just the other day. In fact, I was reading and it popped up in one of my news feeds, and that is the following. So this I will send out to everybody. This is kind of it's a weird and very, very in-depth and detailed explanation of link local addresses and how they affect the use of sockets on a host running IPv6. And I never even thought about it until this particular article, and how it is a problem when you've got the same link local address on multiple interfaces. Because if you do, well, how do you know what interface that is coming in on and how is it related to it? That is, by the way, believe it or not, why I found out that is why on Microsoft machines, you've got this percentage, because that is associating it with a particular interface. So this link local address is associated with this Ethernet adapter. And so the same thing goes on here, and this is what this is talking about. And again, this gets extremely detailed, but this percentage E0 is, or the percentage number is what's being used to associate that link local with a particular interface, which will then allow you to associate that to particular services running on a device. So it's a good little read, but I thought it was worth just kind of showing to you, because with that, I'd never really thought about how that could cause a problem when you're trying to connect to a device all using the same link local IP address. but it makes sense. And that's why you would get the percentage that we're seeing on Microsoft devices, because that's telling it what interface that link local is actually associated with. So I'll send this article out to everybody. Again, it gets very detailed about sockets and about how to represent zone IDs and those type, not zone IDs, but the interfaces that a particular IP address is associated with. But it's a good little read. It's not super in depth, but it's enough that you can understand why we have those percentages and why that could be a problem with things like sockets and binds and connects, because we don't know exactly what interface we're going to unless we use a percent sign and specify that interface, which is what most operating systems are doing today. So FA80:1 %E0, that associates that one with E0, and then %1 would associate it with interface 1. So if E0 was interface 1, it would be 1. And so in our Windows boxes, it's for whatever reason, interface 6, interface 18 is what's being pulled. So I think I'll send this out to everybody. And for everybody who's already here, I will just stick it in chat so that you can have it in chat. So neat little thing there we found. All right. Any other questions about our about what's needed to complete? And here you'll see again. It did not update. Yeah, it actually did update. So you should be able to see now under this course that everything's available to 26. There you go.
Yeah. And Kel, I think last week you said things like dual stack will not be on the exam.
No, I don't remember seeing anything dual stack. You know, dual stack. Well, dual stack will be on the exam. Dual stack is definitely on the exam, because looking at how you use both IPv6 and IPv4, that is definitely on the exam. What's not on the exam is NAT 6-4 and tunneling. Those concepts are there, but they are not on the exam. Okay, but you do need for a hands-on final, you will need to know how to do IPv6 addresses, assign them to an interface, and how to enable IPv6. Which, remember, what's the command to enable IPv6 on a router? What do we use? IPv6 unicast routing. Remember how that makes it start listening to the all routers IPv6 multicast address. So we have to enable that in order for it to be able to actually route IPv6 and to hand out addresses via Slack on a device. So Benjamin, dual stack is on the exam, but NAT 6-4 tunneling, those ideas are there, but configuration of it is not there. But you definitely do have to be able to put IPv6 addresses on interfaces and bring them up and do that. And you may see a simple subnetting of an IPv6 /48. So remember, if I give you 2001 /ACAD: /48, and I ask you to give me two subnets, one to use on two different interfaces, all you have to do is this: 2001 /BBAD: ACAD: 0::/64. Oops, I hit the wrong. Hit a button here. /64. And then your second one would just be, your second subnet is very simply the next line is that. And then you could assign the address : :1 and :1 to your router, so that your router would have 2001 /BBAD: ACAD: 0:1 and 2001 /BBAD: ACAD: 1:1 on the other interface. That's how simple subnetting is, because you'll be handed a /48 and asked to subnet it. You've got that entire hextet to use for subnets. So I picked 0:1, you could pick A, B, you could pick whatever you want to. But for simplicity's sake, it's just the easiest just to do 0:1. Questions about that, about subnetting an IPv6? Okay. I'm actually going to stop my video because we don't need my video. Don't need to see me drinking from my sun drop. If you don't know what Sundrop is, it's a drink that's only really in North Carolina, or actually now it's in more parts of the United States than it used to be. But it was created kind of like cheer wine in this area. All right, let's talk about ICMP. Any questions before I talk about it? Get started here on ICMP and looking at what we need to do to communicate and how ICMP is used. ICMP v4 and v6 is used as a messenger portion of the TCP/IP protocol stack. So common uses are host reachability, destination or service unreachable, and time exceeded. Now remember, one of the cool things about IP, even though IP at layer 3 is not guaranteed delivery, it has in it a hop count mechanism. So it has a mechanism for time exceeded. So if you exceed the hop count, exceed the time, an ICMP message will be sent that's a time exceeded message. For reachability, what we use typically is the ICMP echo request. You send a ping, that ping goes across as an echo request, and if ICMP is allowed, you will get a reply. The big problem we've had to this point now in the real world is that because pings are being used or have been used for nefarious security reasons, i.e. scanning networks, trying to do pings of death by malforming them, most networks do not allow pings to come inside of their network from the outside. And for that reason, ping is not as important of a reachability tool as it used to be. Once we're all using IPv6 public addresses, maybe ping will once again become something that is more globally usable. We still use it locally though, because you got to think, if I was having a problem with my machine right here, and I needed to know, okay, what's wrong with my machine? Why can I not get to the internet? The first thing I'm going to do is I'm going to look at my IP address, which in this case is 10.62, and I'm going to ping my default gateway. So I would just ping 10.102.10.1, and that tells me that I can reach my default gateway. All right. Then I would ping an address on another network. So 10.102. I'm going to try 20.1. All right, so that's on another network. So now I know that at least inside, I can get from the 10 network to the 20 network. And then if I tried to ping, let's say ping www.novell.com, you're going to notice it resolves, but it fails. Okay, and my ping is not going to work. I go up here, go to www.novell.com. I can get to Novell, which is now Micro Focus, which is hilarious because it used to be one of the biggest companies in the world. All right. But you'll notice that the ping failed. So what this tells me is I have access to this site, but ping is being blocked because of security reasons. Okay. But ping, even though I can't ping outside my network, I can use it as a way to test inside my network by looking at pinging my default gateway to see if I can access my own default gateway, and then pinging a remote host. And typically if I can ping a remote host, okay, so that network's not in use. I think this one's in use because that's my lab. Yep, 122.1 is my lab. So this shows me that I have the ability to reach other networks. And so it gives me the belief. I would say if I saw this, I would say, well, I know at least I've got reachability to the 10.102, 122, and the 20 network. But that's how we use ping. We also have the ability to ping certain services. And this is where we were getting in trouble with security. They would use ping to try to find out certain services and protocols that were available and certain ports that were unreachable, and would use that to map out what services are available on a machine using tools such as Imap, port scanners, those types of things. And that's why we ended up blocking ICMP from outside our network. Now, Traceroute, this is also a special tool that uses ICMP echo requests. So if I do a trace RT to 10.102.122.1, trace RT, by the way, is the Windows command for Traceroute. It sends an ICMP echo request with a time to live of 1. So it goes up to my default gateway and then it should have shown my default gateway and then come back. It did this because I am on a multi-layer switch. So it did not actually traverse over even to my default gateway because it was able to bypass it due to express forwarding and the building of layer 3 switch tables. But ICMP Traceroute, let's try this. Let's do a trace. Back to that novell.com. You'll see it's going to go to my 10.102 10.1. That's where it should go first. Then it's going to hop over to the next hop in line, which will be leaving this building and then going down to our main point of, and you notice what they've already done. They've already started with security policies blocking ICMP. So we're blocking ICMP, not allowing it to even on our internal network. We're blocking it. So what this does though is it sends an ICMP echo request with a TTL of 1. When that time exceeded comes back, that information is shown. Then it sends a TTL of 2, then it sends it back, then a TTL of 3, and it does that all the way out to a maximum of 30 hops. But again, just because you can't reach it doesn't necessarily mean that you can't get to it with Traceroute. It just means possibly that ICMP is not allowed across the network. Now, ICMP in version 6 is much, I would say it's much more important, but it's very, very important because it is used to establish SLAC, stateless address auto configuration. So when a PC boots up and it's running SLAC, it sends a router solicitation message. So it says basically, are there any routers out here who have a prefix that I can use to create myself an IP address, a globally routable IP address? The router will then send a router advertisement message and say, yes, this is the prefix we're on, this 2001 DBA ACAD 1::/64. And my link local address is FE80::1. So make that your default gateway. And all of that takes place using ICMP version 6. There's also, using ICMP version 6, routers use what are called neighbor solicitation messages. In other words, remember, when we get this prefix from SLAC, the PC then creates itself a random interface ID. It will actually send a neighbor solicitation message to see if anyone else already has that random IP address, and that helps with duplicate address detection. Okay, so it is very important in our use of SLAC. Again, we send the router solicitation message, we get the router advertisement message back, and then we also have the ability to do neighbor solicitation messages. So if I've got 10, I can send out neighbor solicitation messages. Does anybody else have this? Before I grab it. And of course, 10 would not be the number that would be given there. You also have the ability to use this like we use ARP. So neighbor solicitation messages can be say, hey, who has the IP, the MAC address for this IPv6 address? Send the MAC address, and then it would do so. So I send a neighbor solicitation message to say who is on 1.10 and what is your MAC address, and then the neighbor advertisement will come back and it will give the MAC address. So this is how IPv6 handles what is handled by ARP requests inside of IPv4. These are also sent to multicast address, not to broadcast address. But since everybody actually joins the all IPv6 multicast address, it functions exactly like a broadcast. So to actually say there are no broadcasts, yes, technically that is true in IPv6. However, we're just doing an all host multicast. So it's kind of a splitting hairs there to try to figure out a way to do broadcasts.
Kelly, would that be a trick question on the exam? It sounds like a great trick question for
Yeah, I would be careful with that and just say there are no broadcasts in IPv6. That's the correct answer. Because it is all multicast. Again, real world, it ends up working the same, but yes, I would be careful with that. So how can we use ping for our testing? Well, I showed you, but I didn't ping my local loopback, but you can ping your local loopback. So you can actually just ping. If you ping 127.0.0.1, you see that TCP/IP, the protocol stack is loaded. Doesn't mean you got an IP address, but it does mean you've got it loaded. Then you can ping your default gateway. And then, of course, we ping remote host. And if this works, your host is more than likely working. The only problem that you could have at this point is if DNS is not working. You could be having DNS issues. So you've got layer 3 connectivity, but you've got an application layer problem because DNS is not working. You also can ping : 1, which is the loopback for IPv6, which shows me that IPv6 is loaded on this machine and it's running. Okay. So you do have that possibility. Again, they just show you pinging your default gateway. And just remember, default gateway is always the closest IP address that is on the same network as you on the router interface. And then ping that remote host to see if you've got access. Traceroute, real world, pretty useless. I mean, I hate to say it, but in the real world, Traceroute is just useless. Now, I will say inside the network, I'm actually surprised that they're blocking Icmp in our network between our buildings. Typically, I would not do that because that way you could do you could use Traceroute to trace items between your networks or different buildings and different sections. But for whatever reason, that's what we're doing here. Just remember, every time a packet goes through a router, the TTL is decremented by 1. Okay, at layer 3, that time to live, the hop count is decremented by 1. And when it reaches the max of 30 or 255, it depends. Some of them, actually most of them are 255 for a max. It will then be discarded. So that's a loop prevention mechanism. That way, if you did get in a looping situation, the packet will not loop forever at layer 3. It will actually eventually be discarded because the TTL is exceeded. Questions about Icmp? It's pretty simple, very simple concept.
So in this exam, there's no questions about that are sort of like migration related. We put in this, how does this change the network? It's not going that deep at all, right?
No, it's not going that deep at all. And one thing I will show you, here's something I will show you that's very important, and that I hate to admit took me so long to learn, and I'm kind of ashamed to admit it that it took me this long. But when we're looking at certifications, all right, one of the things that you should always do, and I actually had this really didn't hit me until I started helping create some certification exams one time. So 200-301 is the new CCNA exam. And if you go in here, you can actually see the exam topics. So let's review our exam topics. Here are all the different parts of the exam itself. So there's the network fundamentals is 20%. 20%. Then we got network access is 20. IP connectivity is 25%. So that's why I spend so much time on IPv4 and v6, because those are huge items. But what I want you to notice is download this and use it as a study guide for yourself. And what you need to look at is this verb right here. So you need to explain the function and role of a router. Now we've done that a little bit. We're going to do a whole lot more of that in CCNA 2 and 3. That's when we really get into how routers and switches work, how to configure them, the fun stuff in some ways. Not that this isn't fun, but it's a whole lot of fun doing the hands-on with later on. But you'll notice, describe the characteristics of these. Now we go over these later too, the difference between a tier 2-tier, 3-tier network, spine leaf, which is in a data center, and then on down here. But when you get to this, configure and verify IPv6 addressing and prefix. All right. So if you were going to have a hands-on item on the CCNA and they're going to ask you to do some task, anything that says configure, you better know how to do it. So can you put an IPv4 address on a router, on a switch virtual interface, and on a host? Can you put an IPv6 on there? Same thing as you move on down here. Look under network access, configure VLANs. You can't do that right now. You will be able to when we get done with CCNA 2. You'll be able to do VLANs. You'll be able to do router on a switch. You'll be able to do trunk ports and understand native VLANs and 8021Q. All of that's in our next class. But pay particular attention to that right there. And that will tell you how deep you need to know how to do these things. None of the verbs inside of this CCNA are being able to integrate or are extremely high-level verbs. They are, interpret the components of a routing table. In other words, you're going to be able to look at the routing table on a router, and you're going to be able to tell me what networks are associated with the interfaces on that router. So the connected networks, which we've already looked at in some of our outputs, and you're going to be able to tell me what the network is and the mask, and that all of these things you'll be able to do. But we're not going to ask you to integrate 2 different routing protocols. That's outside the scope of the CCNA now. What we're hoping is that all of you will start using CCNA in your classes. Your students are going to love it. You're going to love it. You're going to love what they're learning. And then my hope is that we can all get back together in a year or so, or maybe next summer as we're doing it, and we can get you started on CCNP classes. And then your students can take it to the next level, and we can start doing CCNP classes with you and give your students an additional opportunity to do those types of classes. That's my hope. And that's where you'll get into the higher level verbs that are, and these are still not low level verbs. These are still, compare the IPv6 unicast or address types, configure it. These are very important though, so that you know how deep you need to study these items. I like to take this for myself. I download it, and then I use this to create myself a study notebook. So I take it, I print this out, and then I have a study notebook. And so when it says explain the role and function of a router, I need to write down router is a layer 3 device, deals with path determination, logical addressing, has a routing table, those things, right? That is how I study for the certification exams. How do y'all do it? Any of you give us some tips on how you do it? What is that link? Oh, I'll give it to you. I'll send it to you right now. I'll send you this.
I think that's great.
This is how I teach my students. There's the link to the exam topics. And what I will also do is I'll download this and I'll put this in our class. I'll actually stick it in our class so that it's available. So let's see, go up here. And I'll add the file. Pop up files. So there's that file. There we go. And so now you've got that in the class itself, so you can just click on it and grab it. Okay. But every Cisco exam has one of these. So any exam you go to do, if you're going to do, like many of you are going to take the CyberOps associate training, if you go in here and look at the exam topics, right here they are. So you can look at the exam topics for CCNA CyberOps. So I strongly recommend that you do this as a studying method for your students and for yourself. This, by the way, is why we're having those of you who are just wanting to take CyberOps. We're also asking you to do this class because it's very hard to understand access control list, NAT, PAT if you don't understand basic networking. Okay. Any other questions before we move on? All right, let's talk about the transport layer. So now we're finally up at the layers that are above our network layer. So we're up here in layer 4, so our transport layer, which is the third layer of our TCP/IP protocol stack. But at this layer, one of the things you will read about is that the transport layer deals with reliable guaranteed delivery. And then that's for the OSI model. That's what it tells you. And then immediately you'll read about in the transport layer of TCP that there or of TCP/IP that there's these two little protocols right here. One is called TCP, and the other one is his unreliable little brother UDP. Now, it's hilarious because we read about the OSI model, and the OSI model says layer 4, the transport layer, is guaranteed reliable delivery. And then you look in the real world example has a protocol that is not guaranteed reliable delivery that works at layer 4. And the reason for that is this. One of the things that they found very quickly is that some applications need guaranteed reliable delivery. We want to make sure that if we are purchasing a stock or if we are doing something that needs to be atomic, which means it either happens or it doesn't. You know, atomic weapons either go off or they don't. There's no in between. There's no small nuclear blast. It either blows up or it doesn't blow up. Well, if we need it to be reliable and guaranteed, then we use TCP. The problem with that is all the overhead associated with TCP that we'll see in a little bit when we look at windowing, sequencing, all of those items that deal with reliability. Well, some applications didn't need that. If we're streaming audio and video, we didn't need that reliability. We need speed. We need to be able to make sure that when we're doing voice over IP, that it's fast. UDP has that low overhead that is needed for us to give quick, fast communication at layer 4. So one of the things that's also very important, as you notice right here, I have Netacat open. I'm connected to the content hub. I'm connected to the Cisco site, 2 different places on the Cisco site. So there has to be a method for my machine to keep up with all of these communications. That is taking place through a socket, which is a special item that we use that is typically an IP address and a port number. Okay, so an IP address, here they are. See all these different things being segmented. So first off, we got to track our multiple conversations because none of us right now, I want everybody just to take 1 second and tell me how many different applications are you connected to on your PC right now? Just
at least 6.
at least. Now, what command do we have that will show us all the ones we're connected to? You remember? Remember this netstack command? That will show us all the different items we're connected to. So we're seeing established, these are all TCP because they're established connections. So netstat shows me all the currently open connections I have to different sites and different applications. All right. Some of these look like they're about to actually end. They're getting ready to drop, which can happen if you stay on a web page a long time. Eventually, it will drop the full 308 handshake with it, and the connection will be no longer valid. I would hate to think how many I'm actually connected to because my email's running. I've got Skype, I've got Teams, I've got the Zoom meeting, everything. So there's got to be a way to keep up with that. There's got to be a way to break everything into segments that are small enough that they don't overwhelm the bandwidth of your media or your medium. We need header information so that we can keep up with those connections. And again, that's how we identify. And this is the ports. This is what we use at layer 4, at the transport layer, to keep up with different multiple connections. TCP port 110 is POP, it's email. TCP port 80 is HTML. TCP 531 is, I always get tickled, they use AOL Instant Messenger, but that's the old AOL Instant Messenger. So as we look here at our different protocols, we can see that down here at the network access layer, remember the beauty of TCP/IP is the creators did not specify any required data link or physical layer components. They were smart enough to leave it down here to where we could rewrite that logical link control. Remember the LLC layer, at the data link layer, rewrite it so it can talk to IPv4 or IPv6. And then above IP, we have TCP and we have UDP. And then those applications above that use one of those 2 protocols in order to keep up with segmenting multiple communications between devices and all of those items using port numbers. So as we look at our port numbers under TCP, we're going to learn about the different port numbers, and we'll see those in a second. Well, it's way down here, but actually I want to jump down here and show it to you. So let's look at the socket pairs here. So a socket pair is an IP address and a port. So here we have the source IP of 1.5 with a source port of 1305. Most of the time when devices connect, they use, oh wow, 30 connections. Holy, that's amazing there. Demetrius, mine's still looking, but 30 is a bunch. So you got a whole lot of stuff open too. Whole lot of stuff. But normally your source port, when you're connecting from a host to a server, the source port is going to be a random number in the available ports. So in this case, this particular host 15 chose 1305 and is connecting to the destination port of 21. Now this is a TCP connection. So TCP 21 tells me that is an FTP connection. And then it's also at the same time connected to the web server. And the way these devices keep up with the communication is through these socket pairs. So this 15.10.99 going to 1780 is a HTTP request. And then when the server responded, it would flip the source and destination IP addresses so that it would come back to the source to this 1099. And then that tells this source where to pass it up to right here. So in other words, if a device gets a request on TCP port 80, it knows to pass that up to a web server. If it gets a request on SMTP, oh God, I'm drawing a blank. I can't believe I'm drawing a blank on SMTP. 25? SMTP is FTP 25, I believe. The only weird one here is DNS, because DNS uses both TCP and UDP. It uses TCP when servers are talking to one another, and it uses UDP when clients are requesting DNS information. Let's jump right back down here and look at our port numbers again. So here, port number groups, here are our well-known ports 0 to 1023. These are typically assigned to applications. Registered ports are here, and they're also can be used typically. They actually can be used for dynamic source ports, but a lot of times the dynamic ports are going to be 49.152 to 65.535 because these are called ephemeral ports, or ports that can be used for source ports from a client to a server. And here's some of our well-known ports. Port 20 and 21, that's FTP, TCP. 22 is SSH. I would memorize a good number of these because it's important to know these as we move forward and as we also start working with access control lists, because we'll create ACLs that block based upon TCP 23, TCP 22, etc. Telnet is TCP 23. SMTP is TCP 25. DNS is the one weirdo that can use both UDP and TCP. DHCP actually does have two different ports, client server port 67 and 68 UDP. TFTP is 69 UDP. HTTP is 80. And also I try to tell people to remember 443 because that's HTTPS. That's another important part. And then IMAP is 143. Anybody, what's the difference between IMAP and POP3? They both are used for client access to email, but what's the main difference between them typically? Anybody remember? The primary difference is this. POP3 was originally designed to always pull your entire mailbox down to your device. And IMAP was designed to give you the option of leaving email on the server and reading it directly from the server. So that was the primary difference between these two. Now, H Simple Mail Transfer Protocol is typically used to send between the clients or between servers. So SMTP is how they send mail between one another. And then these are two client protocols used to pull mail off of email servers.
I'm Kelly.
Yes.
In the future, or like, by the time we'll be teaching this, do you think there'll be updates like for edge computing or IoT? Will they make it this far, or do you see that handled some other way?
Edge computing and IoT is actually a little bit in the third course.
Okay.
The third course, CCNA 3, has a little bit about edge computing, virtualization, and those. The other thing that's really kind of neat is that if you will see inside of here, actually, let me go into course resources. We actually have already an intro to IoT class and an IoT connecting things. So, and even an IoT security class. So there's an entire course that you can use. By the way, you can use it right now if you want to. You don't even have to have training from any of the IoT courses you can use right now with your students. You do not have to take training from us. And as long as you are a Cisco Academy, these are available to you. But that's, so you really could, this talks a lot about like intro to IoT, talks a lot about edge computing and fog computing. So it's there already in another course, and it's touched on in this course. So if you haven't taken a look at those courses, I do strongly recommend going to course resources and going in here and just taking a peek at these. You can create yourself a course right now if you want to, so that you can look at the materials under your own academy. But yeah, these are really good. I probably have an IoT course. We give free courses through what I call my open community college. But yeah, here's intro to IoT. This uses a little bit of the older look to the curriculum, but you can actually see that when we get in our course index here, it talks a little bit about fog computing. There's a flow chart, there's Python, prototyping, challenges of big data, cloud computing. So this is a very basic, about 15-hour module that can be put into any course you're teaching. So if you wanted to do like a basic intro to IoT, I would seriously think about taking the introduction to IoT and just dropping it into one of your courses as an additional module, because it's really good. And in fact,
a project maybe, right?
Or even a project class. Yeah, it'd be excellent for a project class. Because see, this one of the things people don't realize, here's really cool. Check out this packet tracer here. This packet tracer is actually designed to have you add in IoT sensors onto a smart home. So that's built in here. Yeah, let's see if I can. I'm gonna continue as guest right now, but pull that up. So you see here it is. It's gonna make me log in. Let me log in real quick. But you see the lab is actually configuring these IoT devices. So it's really neat. You got these little IoT, you actually can even do programming on it. So you can look at the garage doors, has a variable, and here's all the different. So it's a neat little course. See how it's showing you the temperature, and there's a solar cell that could be providing. It's really cool. So if you're interested in IoT and you want to use some of the IoT stuff, that's a good thing to take a look at. That was a very long answer to yes, it's in there. Sorry. It's just in different sections, and it's also being added as part of semester CCNA 3. So the main differences here between UDP and TCP is UDP is fast, has low overhead. You're going to see it here in a minute when we look at, in fact, let's go ahead and go look at the actual header. Look at the UDP header. Look at how simple it is. That's the entire UDP header. Source, destination, port, lint, checksum, and then anything that's above is the application layer. That's it. So it's a very simple header. Now look at UDP's header. Excuse me, TCP's header. Look at the difference. You can almost see just by looking at these two headers why UDP is faster. You've got this header that's very simple, easy for anything to take apart and look at. And then you've got the header for TCP that is much more involved. You notice here, we've got sequence numbers, we've got acknowledgement numbers, we've got these reserved and control bits. We're going to end up with our different flags that we have in here, our push, urge, reset, fin, and act, and send. So that's one of the reasons why, as we look at these, we can see that UDP very fast, quick to deliver, low overhead. However, UDP doesn't resend any data that's lost, and it doesn't guarantee anything arrives in sequence or intact or unduplicated. It just tries to get it there fast. Okay. TCP, however, is reliable. It is acknowledging of the data using sequencing and using windowing and acknowledgements. It resends lost data and it delivers it in a sequenced order, or at least it will try to deliver it in a sequenced order. And if it is delivered out of order, it will put it back in order using sequence numbers. So let's take a quick look at TCP. First off, TCP always establishes a session, a three-way handshake. When we talk about this with the three-way handshake, it does what's called a send act, and an act. And here's how I relate it to people. I talk about, you call your buddy and say, hey, are you at home? That's my send. Your friend says, yep, I'm here, come on over. That's a send act. And then you say, okay, I'm gonna come over. And then you hang up. So I'm establishing that my friend is at home before I go there. Same thing here. TCP establishes a connection-oriented session to ensure that the two devices can communicate with each other. It also guarantees that it is delivered because it does what is called acknowledgements of X number of amounts of data that are being sent. So we'll talk about all that as we move forward. But again, here's our header. Here's some of the applications that use it. Now let's jump forward into UDP real quickly. UDP, just however it's received is how it gets put in, reconstructed. If it's going to have any error checking, it has to take place at the application layer here. Notice the application layer could do error checking, but there's no real error checking here. There's a checksum, but that's just to make sure it's not damaged in transit. It's not to make sure it arrives in sequence in any way. You notice the datagram header and data. Okay, so it does make sure that it's at least not damaged, but that's it. And if it is damaged and the checksum's not matched, all it does is throw it away. It doesn't try to resend it. So there's very little that UDP can do for you other than be fast. Okay, I've already talked about port numbers and these socket pairs. So I feel like we can go ahead and go through here, and we've used the netstat command. Established is when you've got a full TCP connection. So you've done a send act, and an act, and you have an established connection to a device. So let's look at TCP. So the first thing that's going to happen is if you want to send a request, you're going to end up with what's called the three-way handshake. So we're going to send a send, which says, are you at home? We're going to get back a send act. So in other words, my sequence number that I was sent is incremented by 1 in the acknowledgement. And then host B will send me their sequence number. And then I will act their sequence number. And at this point, I have an established session. This is what's called a half open connection. And there's actually a thing called a send flood that's a security issue where we spoof a large number of IP addresses, send a lot of send floods to a device, and try to fill up its half full queue or half open queue. There have been ways around this now. Actually, most next generation firewalls will actually go ahead and act a three-way handshake to the internal device to keep it from having a problem with send floods. That used to be a known problem. So this is a half open connection, and B only has so many slots for half open connection. So if you could fill up all those, you could actually do a denial of service attack on host B. Our hope, though, is the full three-way handshake takes place and we have an established session between A and B. We then also have termination. So we can have what's called a fin. And this is what I call, this is when you break up with somebody by actually contacting them and say, hey, it's not going to work out. You send a fin, you get an act, they send a fin, and then you act. So basically this relationship's not going to work out. Okay, I agree with you, it's not going to work out. There's another way you can do drop a TCP connection, which is by sending a reset. That's when you just quit calling the person and quit talking to them instead of breaking up with them in person.
Kelly.
Yes.
For each one of the modules, do you recommend us to try to make each module a technical interviewing thing, or how would you manage preparing students for technical interviews? Which do you pick the 3 top things you think job or industry needs, or how do you go about that?
That's what I would do. Yeah, I would do the 3 top things. I really would. Now you're saying a technical interview, you're talking about actually giving them.
So I'm saying Cisco is coming to my campus in 2 weeks.
Okay.
They need to be ready to at least be attractive and talk the lingo and
okay.
And get the foot in the door for a technical interview at least, so they have at least a little time to prep.
Okay. What I would do then, there's a couple things I would do. I don't know who's coming to interview, but if it's going to be more of a technical interview, then I would make sure that your students run them through a quick scenario of troubleshooting. All right. And say, okay, a user is called with a problem with their router. It's not connecting. What would you do? They're not looking for them to understand completely how a router works. What they're wanting to do is to see if they'll say, you know, ask the questions. What has changed?
Like a help desk approach, Help desk approach.
Yeah, that's one of the things I would do, is just make sure they're aware of that in case they get a question like that. We do in Skills USA every year, we require a help desk call. We actually call them on a voice over IP phone and give them a scenario. And we're not grading them on whether or not they can fix the scenario. They get a couple extra points if they do, but it's, hello, my name is Kelly. Can I get a callback number? You know, and obviously they're not going to do that with this, but they're going to be, when they're interviewed, I would have them, you know, understand that if they get a question about troubleshooting, show a method to troubleshoot. I'm going to troubleshoot from layer 1 to layer 7. That's where the OSI model is so good. You know, that's really, do I have blinky lights? You know, are the lights on? Do I have connectivity lights? Can I ping my default gateway? Can I do those things? Now, if these folks coming in are not technical folks, now it gets a little bit different, but they're still going to look and ask you how you're going to solve questions. And I think the big thing there is to say, I am not, if you don't know the answer, that's okay. Just say, you know, I don't know the answer, but I would go and I would look up or Google so-and-so. Or one of my favorite things is, I'm going to be working in a team, right? The answer is probably 99% of the time will be yes. I would go to one of my teammates and ask them if they have seen a similar problem and if they have any suggestions, because that's the kind of thing they're looking for, is to see if your students are willing to go and find the answers. Nobody knows all the answers, but do we have the ability to find the answers? So that's what I would do with that technical interview, and just have them. I think a big thing too is if they're accustomed to being around you. So I would try to get some folks who are not in their daily, you know, in their daily sphere of influence, and have them come in and do some mock interviews before Cisco gets there. That way they'll be a little bit nervous with them, and it will help them, you know, when they interview with somebody they don't know. You can do it, but they're comfortable with you. They've been in the classroom with you. They've interacted with you. Bring in somebody they've never met before, and then that puts a whole new spin on things. I hope that helps. But yeah, we try to always we try our best to make sure our students do mock interviews and do mock help desk calls, because those help desk calls are, you know, honestly, the jobs they're going to get at Cisco are going to be in TAC. There's 2 different jobs they're going to have. There's either TAC in the technical assistance call center, or they're going to be what's called a customer service engineer. And those engineers work with individual customers. Most students straight out of school end up in TAC doing phone support. So showing that they can do phone support is very important. Does that help, Benjamin?
Yes, awesome, awesome. Thank you.
Okay. The other thing, Benjamin, if you're interested, if you want us to try to do some things for your students, we can do some Zoom calls with them to try to get them accustomed. You know, like I said, they wouldn't know me, they wouldn't know my the guys and folks that work with me, so it'd be a good chance for us to
Yeah, that sounds great.
Set that up. So email me and let's set something up. Maybe we could do it before. We'll do it before Cisco gets on your campus. That way they can give them some experience.
Okay,
It
great.
could be
Awesome.
5 minutes, and we could literally just do a quick Zoom call and just try to get them a little more experience in a job interview situation.
Yes, thank you, thank you.
Okay, so the other thing here are these control bits that are part of TCP. If you've ever seen Imap and you've seen a Christmas tree scan, a Christmas tree scan is a scan where every one of these have been turned on. And so there's an urge, act, push, reset, send, and fin. And these are used in the establishment, maintenance, and then the termination of sessions by TCP. We got a couple more minutes here. I just want to real quickly. Now, guaranteed order delivery is handled by sequencing, by sequence numbers. So even if they take different routes and they arrive out of order, because the sequence numbers or sequence segments are marked with sequence numbers, they can be put back in order. We also have what's called windowing. In other words, by default, there's a window size in TCP. And after that window size has been met, an acknowledgement has to be sent. In this case, you'll notice it sent segment 1, segment 2, but it did not get segments 3 and 4. So B act 3 and said, I need everything after 3. And so it started resending at 3. And then it got to 10 and it said, okay, I've got through 10, give me 11. The beauty of the window size is, one, you don't ever want it to be a single segment because then you'd be acting every single segment. But Windows has the ability to do what's called a sliding window size. So it can start out a certain size, and then as there's no lost segments, it can expand it and make it bigger. One of the problems that Windows 95 had was that it did not have a big enough initial window size for TCP, and it was actually inefficient. And so there used to be, back in the old days, we'd go into our registry and change that. Don't have to do that anymore. But here you can see again, it's that window. It can acknowledge. Now this is called selective acknowledgement. This is, you'll notice here, it sent 1, 2, and 2, and it also sent 5 through 10. So it got 1, 2, 5 through 10, but because of this is not selective acknowledgement, it act 3 and then resent everything after 3. This is called selective acknowledgement. So it's saying act 3 and 5 through 10. So it's saying, hey, I got, I didn't get 3, but I got 5 through 10. So I need 3, 4, and so on and so forth. So with selective acknowledgement, we can be even more efficient because we can just acknowledge those that we have received and then receive those that we did not. Now, there's a bunch of good videos here that show this maximum window size and segment size. This basically shows that during that 3-way handshake, we determine a maximum window size, which is that sliding window for acknowledgements, and a maximum segment size, which typically for everything that is Ethernet based is 1460. That way you've got the overhead associated with the Ethernet frame type. Okay. And then congestion control, actually, the cool thing about TCP2 is it can tell the other side to slow down. Slow down, we need to decrease the window size. That can take place. And then I love this. Okay, here's UDP. It just sends it out there and hopes it works. That's really how it works. And if you're going to do any type of communication that requires it to be acknowledged or any type of retransmissions, it all has to be handled by the application that is using UDP. It's not handled by UDP. Now, I will tell you that Radius is one of the applications that uses UDP. It uses port 1812 is one of the ports used by UDP. Radius. So that's one thing you may want to know. That shows up on occasion, 1812, 1813. Okay. Questions about the transport layer? we're down to our last really 3 things here, and I think I've already gone over. We'll talk about how to do SSH, which is one of the last major items that's in on your hands-on final. We'll talk about that. I actually went over it in my CCNA 1, the Monday class a couple weeks ago, but we'll do that and we will be on our way. So I'm gonna stop sharing. Any questions, everybody? Took my hat off. My hair looks terrible. Sorry. Put my hat back on. Any questions? Any problems with class? Hey, Uzma, I didn't see you come in. Good to see you. All right. Well, please let me know if you do have any issues or any problems. Again, we've got up until July 26th to finish this course. So please work towards getting finished, and then that way we'll get everybody moved forward to CCNA 2. And I'm super excited to do that and get you going. So